Hey, what's up? It's your old pal, Mr. Cook. We were working on the quiz review 6.1 to 6.4, and we just got through working with the exponent problems for 6.1 and 6.2. Now we're going to work on some of the stuff that we covered in 6.3. So one really easy thing that we covered in 6.3 was just using our calculator to find logarithms. So that's what we're going to do for this first part right here. And luckily it's like pretty easy, and any scientific calculator has logarithms in it. And I'm going to show you a couple different ways to find logs, using a scientific calculator and graphing calculator, both of which are pretty common. So first off, if I want to use a calculator to approximate this to the nearest thousandths, when it says that to the nearest thousandth, that just means the 3 decimal places. So that's what we're going to round everything to. So here we go. Log base 6 of 24. Well, if you look on this calculator, there's not like a button that has log base something of log of a number, but there is just a regular log button, and if you press it, it just says log of what? Well, here's the deal. When you put together a logarithm on a scientific calculator like this, you're going to have to use a log property to evaluate this answer. And the log property is something called the change of base formula, but we don't really use it to change bases too often in this class. We just use it kind of like as a stopgap for everybody that needs to use a scientific calculator. Like a catch-all, I guess, is more appropriate to say there. So everybody that even has like a scientific calculator can find a logarithm of a log with a base other than 10. Here's how you do it. So if you want to find the log of a of y, just two numbers, it's the same thing as saying the log of y over the log of a. I like to remember it like this, and here's something that you guys can remember if you choose to. If I want to find the log and I have a little base right there, and I just have a little regular old scientific calculator like this, or even a graphing calculator like this, it always works. It's the log of the big number over the log of the little number. So the log of the big number over the log of the base. That's what this is basically saying. So how does that translate to this stuff? Well, to find this log, all I need to do is take the log on my calculator of the big number, 24, and then divide that by the log of the little number, the base, so 6. And then it's probably going to be an approximate value, so let's see what that's going to end up being. So I take the log of 24, close the parentheses, divide it by the log of, where's the log? There's the log of 6. And you hit enter. You get your answer, which is 1 point, and then we got to go 3 decimal places. 7, 7, and then 3, and 7, so that's going to round up to a 4. So there's my answer, 1.774. So let me show you how that looks with a graphing calculator to get the exact same answer there. So it would be log of 24 divided by log of 6. And then enter, and see you get the same answer. So just using the little log button right over here. Now, some of these graphing calculators actually has a really neat little piece of programming built into it. If you hit the math button right here and then scroll up a couple times, so use the up arrow and go to log base and hit enter, then it formats it exactly the way that it's written here with a base. So you can type in 6 and 24 and you get the same exact answer. So once again, that's math and then up to log base. Now, not all scientific calculators have, not many of the scientific calculators have that. In fact, the only one I've seen that has that is the TI 36X Pro. That has that same thing. If you hit log a couple times, it brings up log base, which is pretty cool. And these are like $20 calculators. They're pretty nice. But the rest of them, like with the graphing calculators even, it's not guaranteed that you'll get that log base formula. Like I think the TI-83s and the TI-83 Pluses don't have that. And some of the TI-84s that are older don't have it either. And obviously, like this scientific calculator doesn't have it. The next thing is the natural log. So natural log of 4, that's what that LN stands for there, natural log. So natural log is usually found right around the same place as the log button. So like here's the log button, the LN button's right below it, natural log. And you just type in the number 44 and then enter, and we get our answer. So it's going to be about equal to 3.784. And it's the same, right by the log button, the LN button is on this one. Okay, moving on. So that's those ones, pretty easy, just calculator work. And when you see calculator work, that should be, a piece of cake for you. Same thing for these ones. So we went over like this little conversion from an exponent into a log. That's what we're going to be using for these next 4 problems. Just rewriting in, I'm actually skipping ahead a little bit. That's going to be used for number 11 and number 12. and also 13 and 14 to convert. But we're still going to use it, use this property over here as well. Let me show you how. So this one says to evaluate each expression using the exponents and to give an exact solution. So here's how you do these ones. These are like kind of convoluted versions of these problems here, but much simpler. Just like it takes a little bit of time to get to them. So what you do is you set the logarithm equal to x, so set both of them equal to x like this, and then convert it into an exponent. So if you remember, the conversion goes like this: log of a of y equals x. So if I want to rewrite that as an exponent, it's a to the power of x equals y. So just following that same rule, my a value is 2, so that's 2 to the power of x, and x is x in this case, equals y, and y is 32. So what this is one of those find the same base, find the like base and solve problems. So that's pretty easy to do because 32 is 2 to the power of 5. So I'm just going to convert that. So 2 to the x equals, and then 32 is the same thing as saying 2 to the 5th. And when I have the same base, I can set the powers equal. So that means that x equals 5. So there's my exact answer there. And then same thing over here. I just convert it from a logarithm into an exponent. So if I have log a of y equals x, that's the same thing as saying a to the power of x equals y. Now let's rewrite this as an exponent. So it's 2 to the power of x, which is x, equals y, which is 1 over 16. And remember that trick I showed you in the earlier video. If you have 1 over a number, that's the same as saying that number to the power of -1. And it just so happens that 16 is 2 to the 4th. So this is 2 to the x equals 2 to the 4th to the -1. So that means that I get 2 to the x is equal to 2 to the -4th. And therefore x is going to be equal to -4. So there's our answer. So we're using this property, and we're going to continue to use it a lot. So especially in these ones where it says to rewrite the equation in exponential form, these are so easy as long as you know how to use that rule. See, watch. All right, so once again, log a of y equals x can be rewritten as a to the x equals y. Okay, so I'm just going to rewrite it, and then I'm done. That's it. That's in exponential form once it's rewritten like this. So my a value is 16, so I get 16 to the power of x, which is 2, and then that's equal to y, which is 256. There we go. Once I convert it into that form, I'm all done. So I'm going to do the same thing here. Log base a of y equals x. Okay, here we go. So a to the power of x equals y. Ready? So my a value is x, so x, and then to the power of x, which is y, equals, and then y, which is 60. So x to the y equals 60 is the expression rewritten in exponential form. All right, now for the next one, or the next couple problems, we're going to do the opposite. We're going to start in exponential form, and we're going to rewrite it in logarithmic form. So I'm going to write the log part and the exponent part first, so a to the x equals y, and the conversion to a log looks like this. Log base a of y equals x. So rewriting this exponent as a log, it's going to be log with a base of a is 16 in this case, so base 16 of y, which is 256, and then that's equal to my x value, which is 2. So there's the answer for that one. Now it's rewritten as a logarithm. Let's do the same thing here. So we have a to the power of x equals y, and writing that as a log, it's log base a of y equals x. So here we go. My a value is u, so I get log of u, and then my y value is 52, so that's the parentheses 52, equals my x value, so my x value is v, so equals v. There it is, rewritten as a logarithm. All right, so this concludes all the ones that we're going to do for this video, because that's all the 6.3 stuff, because every one of these little problems that we've worked on so far have come from 6.3. So if you need some additional help or some additional examples, make sure that you check out some of those problems from 6.3. They're really helpful to work on, especially in a quiz like this, because this quiz is really heavy with calculators and just using that one little property of converting from exponents to logs. Okay, so that's it for this video, and then we're going to work on the last video, which is going to be solving, and that one shouldn't take much time at all. All right, on to the next video.